Yo, what's up? AP Pre-Calculus. Let's find some solutions to some more quadratics. Uh, quadratics, ax squared plus bx plus c. If they can't be factored, or if you're not sure what you're doing, you can always use a quadratic formula, which smart mathematicians figured out this formula by completing the square and like using factoring and simplification to kind of solve any generic ax squared plus bx plus c. The quadratic formula is by taking the opposite of b over 2a plus or minus the square roots of b squared minus 4ac all over 2a. Now, this is one version of the quadratic formula. The other version of the quadratic formula is having the common denominator kind of in the bottom. I like to keep it separated because I like to, and we talked about this in class, think about, how if you have a quadratic equation, you're going to have a middle, okay? It's called the vertex. And since the quadratic equation has symmetry, if you have one, say 0, we'll put it right there, it's going to be the same distance to the middle as your other 0. So I like to see that kind of symmetry in the quadratic formula, which is why I like the top version of the quadratic formula. Because we can see this would be the x location of the middle, and then this is going to be, and this is all of it, like the distance to both solutions. This distance subtracting from the middle, this distance adding from the middle would get our solutions, distance to our solutions. Okay? There are some times our quadratic will not have real zeros that you can see. They will not cross the x-axis. However, there will be solutions, like we'll call them imaginary numbers, that theoretically can go into the equation and solve the equation. And we'll get into that. So the first thing you should be checking, especially if we're thinking about getting to the test and just having a quadratic and seeing like, can you make your life easy and factor this? Can you do 3 times 1, which is 3? Can you find 2 numbers that multiply to get 3 and add to get to -6? And it's like, no, I can't. So this is when if factoring fails, which is easier, or if you always want to use the quadratic, you can. Quadratic formula, you can. It's always a good backup. We go to the quadratic. Now, I identify A, B, and C. A is 3, B is -6, C is 1, and I take the opposite of B over 2 times A. Plus or minus, since I'm not using a calculator, I'm doing some of the work of B squared minus 4AC in my head. So first, B squared is -6 squared. I'm going to write -6 squared is 36. Minus 4 times A times C. That's 4 times 3 times 1, and that's 12. And that's over 2A. I'll be right back. Good. Sure. If you do it towards the beginning of the period, it might be better. But I guess that's the end. I've B lunch too. If you hold them around, I mean, I guess you're 11:30. B lunch is 1. Okay, yeah, whatever. Bring him over. I'll say hi. I mean, like, he's gonna be fun. Oh, listen, it might be the perfect person for this class. And we just have to tell him, yo, we're just gonna keep it easy. It's almost like, yo, reteach them math. You love math, reteach these kids math. Okay, good. Thanks, man. Sorry about that. We got a little bit of drama going on in the math department. And I'm the department chair. Okay, now what am I going to do? I'm going to like simplify 6 divided by 6. Okay, don't do 6 divided. I mean, you can do whatever you want, but it's like order of operations are probably working on the bottom first. 2 times 3 is 6. So I get 6 over 6 is 1. This becomes, and I'll do this work on the side, the square root of 36 minus 12. If you got to do it up here, do it. You're not going to have a calculator. You get 24. Okay, so I got the square root of 24 over 6. Now remember, we need to try to rationalize and simplify. This is mostly the case because we will have multiple choice questions on our tests. Multiple choice questions will always be in like simplest, historically simplest form, which means just you have to rationalize. You find the biggest square root that goes into 24. 4 times 6 is 24. Root 4 times root 6 is root 24. Root 4 is 2. So I got 1 plus or minus 2 root 6 over 6. The last thing I can do is divide the top and bottom by 2, makes that 2 go away, makes this 6 turn into a 3. All of this needs to be done without a calculator. You cannot simplify a square root with a whole number, so this is it. Here is the x coordinate of the vertex. Here is my distance to the solutions. If you take the vertex plus the distance, you get one solution. Vertex minus the distance, you get the other solution. Let's go ahead and do the other one. You need things in standard form, so I'm going to subtract the 4x over. I'm going to see if I can factor two numbers that multiply to get 20 and add to get 4. I'm thinking 10 and 2, 5 and 4, 20 and 1. Can't do it, so instead, I got to use my quadratic formula. I'm going to keep it to the split up version because I prefer the split up version. It keeps things in like simplest form. A plus, a vertex plus a distance. So keeping it at that. I got the opposite of b over 2 times a. A is 1. B is negative 4. C is 20. Plus or minus square root of b squared. Do the math in your head. Minus 4 times a times c. I'm probably doing that in my head and saying it's 80. Now I noticed something. I'm going to have a square root of a negative. That means we don't have any real solutions we can see. These solutions are going to be complex. They're like theoretical solutions, square roots of negatives that can be plugged into the original equation to solve it. Doing a little bit of work, 4 divided by 2 is 2. 80 minus 16, I'm going to do 64. So I got the square root of negative 64 over 2. This is where we split up our square root of a negative, and we're going to use different notation so that we don't have square roots of negatives, because the square root of negative 1, we use the letter I to say this is an imaginary solution. It is a theoretical solution. You can't take the square root of a negative number. It doesn't equal negative 8. The square root of negative 64 is 8i, because no number times itself gives us a negative. Like negative 8 times negative 8 is positive 64. All right, giving me my two complex solutions, 2 plus or minus 8i over 2. Divide the top and bottom of this by 2, and I get 2 plus or minus 4i. Cool? Great. Whoa. Cool. All right. Find the zeros. X squared plus 2x minus 6 equals 0. Are there two numbers that multiply to get negative 6 and add to get 2? No. Back up. / first choice. It's up to you. Quadratic formula. Opposite of b over 2a. Identifying a, b, and c. Plus or minus square root b squared minus 4 times 1 times negative 6. 4 times 1 times negative 6 is negative 24, so I'm subtracting negative 24, which is adding positive 24. We got to be able to do this math in our head, / don't make mistakes with it. That becomes the square root of 28, okay? So I got 2 over 2, which is 1. I got the square root of 28, which simplifies to be root 4 root 7. So I get 2 root 7 over 2. That is 1 plus or minus root 7. Our two solutions are 1 plus root 7 and 1 minus root 7, but you're allowed to leave your answers like this versus writing them out separately. Yo, finding the vertex. Boom. I know where the middle of my quadratic has to be, right there at 1, because like that's got to be the middle. I add a distance, I get to one solution. I subtract the same distance, I get to the other solution. Quadratics are symmetrical, so that's great. So I know the x coordinate is 1. We're asked to find the vertex, so we want to find the y coordinate as well. So this is where we're just going to plug in 1 to find the output of this quadratic. 1 plus 2 minus 6. 3 minus 6 is negative 3. So I got the point 1, negative 3, which is the location of the vertex. While you're doing your homework, it's always good to potentially check. I know you guys like to use like photo math or something, but it's easy as just like using Desmos or using a graphing calculator. I'm going to use Desmos just because I like to make sure I'm getting the right answers too. And what we can do is literally just graph the equation, y equals 3x squared minus 6x plus 1. And you can literally find the zeros, 1.816, 0.184. You could find the location of the vertex, which is at 1. You can do the work 1 plus root 6 over 3. You squirt. And you get 1.816. So it's like, boom, we just found that. And I know the other one's going to be right. This one, we would have to use a different program to find the complex solutions. But for now, you can just see, oh, there are no real solutions. This graph does not cross over the x-axis, so the imaginary solutions make sense to me. And then x squared plus 2x minus 6. Boom, 1.646. And if I did 1 plus root 7, I get 1 point. Uh-oh. So this is why we check this. Negative 1. Yo. Opposite of B over 2A. Negative 1. Negative 1. But I feel like that's still going to be, no, that'll be right. 1.646. Boom. All right, so yeah, yo. Classic Mr. Messner talking and not thinking. Make sure you have the formula correct in your brain. Make sure you're doing the opposite of B over 2A. Find all solutions to the equation. This equals negative 16. So I'm going to take the equation x squared plus 2x minus 6 and set it equal to negative 16. To solve this, I'm going to get everything onto one side. Add 16. 16 minus 6 is 10. I'm feeling like there are going to be some complex solutions. Yep. So there are solutions to this. They're not actual numbers. They're imaginary numbers. They're more theoretical. X equals, let's not make the mistake again, the opposite of B over 2 times A, plus or minus the square root of B squared, minus 4 times 1 times 10, all over 2 times A. Square root of negative 36 is 4 minus 40. That's the square root of 36, which is a perfect square, times the square root of negative 1. That is 6i. I get x equals negative 1 plus or minus 6i over 2. Divide the top and bottom by 2. I get x equals negative 1 plus or minus 3i. Okay? Cool. Looks different. This is in factored form. Find the x and y intercepts of the graph. Well, that's easy because it's factored form. X intercepts when y is 0. Setting the equation equal to 0, I get my zero product property solutions, positive 5 and negative 3. The y intercept is when x is 0. Plugging in 0 in for h, for x in the function h, plugging in 0, I get 2 times -5 times +3. I should probably put 0 plus 3. And I get 2 times -5 times 3. 2 times -5 is -10 times 3 is -30. Okay, so there's the y-intercept. Find the vertex. Okay, now this is where we have options. We can use the fact that you know the locations of the zeros. You know the zeros at 5 and -3. This is very important to think about this, and this is like going the opposite way of like how we were thinking about finding the vertex. We were using the quadratic formula to find the vertex and then find the distance to the solutions. Well, if I know what my solutions are, I know the vertex has to be smack dab in between those solutions, right? If it's symmetrical and you know 2 points, the middle, the vertex has to be smack dab in the middle of those 2 numbers. How do you find the middle of the 2 numbers? You like average the 2 numbers together. So option 1 is to find the average or the middle of your zeros. Add the 2 numbers together, divide by 2. That's how you find the average. You get 1. I mean, I'm literally saying the number 1. 1, 2, 3, 4, 5, a distance of 4. 1, 0, -1, -2, -3. The distance is 4. So yeah, 1 is smack dab in the middle. So this is the x-coordinate of the vertex. We'll have to find the y-coordinates. The other option is using the quadratic formula. Now, this is a tougher option because you'd have to distribute everything. Now, you're experts at distribution, so you're good at getting this, but then you got to do the opposite of b over 2 times a, which is 1. I mean, that takes a little bit more time to do. And I probably would rather do this if it was easier to do. Find just like the midpoint, average, same. The y-coordinate, plugging in 1 into the original equation, it's probably easy enough to do 2 times -4, plugging in 1 times 4. So I get -16 times 2, which is -32. If we graphed 2, x minus 5, x plus 3, you get 1, -32, 5, -3. Solve the equation, this equal to -29. Now, I'm glad I actually did distribute because this is the only way we can solve this equation, is by taking the standard form, set equal to 0, and then kind of simplify, look to factor. I'm going to add 29. I get 2x squared minus 4x minus 1 equals 0. Boom. 2 numbers that multiply to get -2 and add to get -4. Can't do it. Straight to the quadratic formula. X equals the opposite of b, don't forget that, over 2 times a, plus or minus the square root of b squared minus 4 times 2 times -1. 4 times 2 is 8, times -1 is -8, so 16 minus -8, and that's all over 2 times a. I'm going to simplify this. It's the square root of 24, which is the square root of 4 times the square root of 6, which is 2 root 6. So I'm going to put my answers, x equals 1 plus or minus 2 root 6 over 4. Let's go ahead and divide the top and bottom by 2. 1 plus or minus root 6 over 2. We can find the intersections. 2.225. 2.225. There you go. It's actually 2.22474. That's the correct answer, but boom, we got it. All right, Don't forget, you don't have to use the quadratic formula if you don't have to. Like, if you can isolate your x and just get x by itself, if you could factor, that's what I'm looking to do first. I don't like using the quadratic formula. It's just like a little bit messy, especially if like you're missing terms or if like they would force you to distribute before using the quadratic formula. I would instead like to maybe isolate the x squared. I subtracted 2, I divided by 18, you get negative 1/9 by dividing the top and the bottom by 2. Square rooting both sides. Okay, x could equal plus or minus. Properties of exponents, you could take the square root of the top and the square root of the bottom. The square root of the top is I. Square root of the bottom is 3. I probably would want to write this as 1/3 I, not I over 3. You can put a 1 here and I here. Like if you think about 1/3 times I, that can look like 1/3 times I over 1. It could look like I over 3, but like you could also keep the 1 here, bring the I out. You should be comfortable with that, but a lot of you I'm sure are not. You're unsure about simplifying. But that's the answer there. We are looking for the complex solutions. You'll always have 2. There's always a pair of complex solutions. It's nice that they told you you're going to get it. On the test that you're going to get, it's not guaranteed. Like, you're going to be told, hey, this one has complex solutions. Give them to me. You have to, like, figure it out. It's like, oh, I'm taking the square root of a negative. The square root of a negative cannot be done to get a real number, but it's could be part of a solution to this equation. Using a square root of a negative in the original equation can solve the equation. Don't forget your plus or minus. Finish things up by adding 3. You can't add 3 to i's. They're different pieces of fruit, so we just get that. All right, I'm going to do the easy way because I told you if you could factor, you should probably factor. So I think the easy way is to have this factored because we can easily find the zeros. The zero product property gives us our zeros t equals 0 and t equals 2. The vertex has to be smack dab in the middle. I don't even have to do any math. What's in between 0 and 2? 1. It's a t value, not an x value. Whatever, if you use x's or t's, we'll be more strict about that stuff in the future. Finding the y coordinate, you plug in 1, you get negative 1, so boom. There's the vertex, there's your zeros. Find the solutions to t squared minus 2t equals negative 26. I feel like I've seen this number before, this negative 26. I don't know why. Oh man, 13 and 2, don't add to get negative 2. 26 and 1, nope. I gotta use the quadratic formula. Set equal to 0, I added 26. So I get x equals the opposite of b over 2 times a, plus or minus the square root. Did I take the opposite of b? Yes. Okay, good. I made that mistake before. Learn from your mistakes, team. B squared. 4 times 1 times 26. I'm going to do this on the side. 4 times 26. 104. 4 minus 104. Oh, man, who set up this problem? This is sweet. All over 2 times a. 2 over 2 is 1. The square root of negative 100 is the square root of 100, which is 10, times the square root of negative 1, which is I. So this is 10i over 2. We get 1 plus or minus 5i after dividing the top and bottom by 2. Cool. These are just like extras. Like, I don't think this is worded nicely, but the situation is like, yo, set P of t, which is t squared minus 2t, equal to negative t squared minus 1. I can see how some of you might be confused by how this is worded. You're like setting this equal to 0, but we did not establish that P of t is changing. Like P is this function, t squared minus 2t, and we're setting that function equal to negative t squared minus 1. If that confused you, don't stress. Like, ask questions, like if you have this on the quiz, and we'll make sure we clarify it. But I add t squared, I get 2t squared. I add 1, I get positive 1. Two numbers that multiply to get 2 and add to get negative 2, I can't do. So I have to use the quadratic formula. X equals the opposite of b over 2 times a, plus or minus the square root b squared 4 minus 4 times 2 times 1, which is 8. So it's 4 minus 8 all over 2a. 4 minus 8 is negative 4. Square root of negative 4 is 2i. So I get a half plus or minus a half I after dividing by 2, top and bottom. Same thing here, t squared minus 2t equals 2t minus 5. I'm going to subtract 2t. Unfortunately, the 2t's don't go away. I'm going to add 5. Two numbers that multiply to get 5 and add to get negative 4. No! They have to be both negative or both positive. I wonder if we wanted this to be nice. By we, I mean like the teachers who made these problems. 4 times 1 times 5. All right, whatever. It actually works out nicely. 4 times 1 times 5 is 20. 16 minus 20 is negative 4. So I get 4 over 2 plus or minus 2i over 2. So I get 2 plus or minus I. All right, this I can solve. Yo, we're giving you really good practice. There's a lot of good problems. I'm going to even say maybe a couple too many problems in here. Maybe a couple too many problems in here. Maybe we've done it enough times that we don't have to do all of these problems. So maybe I'm skimming through this right now as a student and being like, yeah, I'm crushing. This is annoying. Oh, last page is empty. Okay, never mind. I thought the last page is going to be some extras. Okay, never mind. It was perfect. This is a perfect homework for you guys. Good practice, complex solutions, quadratic formula, arithmetic, no calculators. Looking good. I'm sure I made a mistake, but I'm not going to check. If you found mistakes, good for you. We'll go over those mistakes in class. Mr. Messers out.